So today we're going to talk about the unit circle and coterminal angles, and really, in some regards, we're pulling things all together. So I doubt that we will get through all of the examples, because as we work through these, I hope that you're saying that we've already done this before. So it's just maybe one little step more than what we've already been doing. And the key is here, what do we do if the angle value that we're working with isn't an angle value on our unit circle? Well, the answer to that question is we first find the coterminal angle by adding or subtracting 2 pi, and that will also allow us to identify the quadrant, and then we can follow our steps like we do for any other problems. So when we look at our first example here, the 8 pi over 3, 8 pi over 3 isn't a value that's on our unit circle. But if we subtract 2 pi from that value, remember when we're finding a common denominator, to subtract we have to find the common denominator. And the common denominator between 3 and 1 is 3. So the 8 pi over 3 doesn't change. But 2 pi over 1 is the same thing as 6 pi over 3. So we did 1 times 3 is 3. So 2 times 3 is 6. This is the common denominator part. The 6 pi over 3 is the common denominator part. Well, 8 pi over 3 minus 6 pi over 3 is 2 pi over 3. Is that a value that we have on our unit circle? Yes. And since we're really working this weekend next on knowing the unit circle completely, a couple things. First of all, our coterminal angle is what we just found. It's the 2 pi divided by 3. What's our reference angle? It's pi over 3. And we could have done that even before we did any of this problem. Well, what quadrant is 2 pi over 3 in? It's in quadrant 2. If you don't like the Roman numeral, then write the regular number, knowing that if you take this class in college, they're probably going to want the Roman numeral. Well, the ordered pair for our reference angle then is 1/2 radical 3 over 2. We're in quadrant 2, so do we need to put any negatives in there? Which value? 1/2. We went left 1, and then we went up 2. Is that right? That's not right. The 2 is the hypotenuse, but we went left 1. That part is right. So now, once we identify the ordered pair, then we can really answer our questions. Because remember, first of all, sine of 8 pi over 3. Sine is going to be our second value. Cosine's the first value in our ordered pair. It's negative 1/2. And I peeked in yesterday on Mr. Jarvis, but I didn't see a lot. But remember that what he was talking to you about yesterday is that tangent is sine divided by cosine. I like to go old school. You don't have to. But sine is radical 3 over 2. And cosine is the negative 1/2. When dividing, don't ask why. Flip the second one and multiply. So when we do that here, we get radical 3 over 2 times 2 over negative 1. The 2's cancel out. 2 divided by 2 is 1. We can multiply the tops together. Radical 3 times 1. 1 times negative 1. Which gives us radical 3 over negative 1, which maybe is best written as negative radical 3. Well, now that we know that, we can find our reciprocal values. And cosecant is the reciprocal of sine. So that's going to be 2 divided by radical 3. And secant is the reciprocal of cosine. So that's going to be 2 divided by -1. No, you don't have to write 2 divided by -1. Perfectly fine to write -2. In fact, we don't really like having a negative in the denominator. We don't really like having a radical in the denominator, so we're going to have to deal with a couple things. But cotangent of 8 pi over 3, cotangent is the reciprocal of tangent, so this becomes 1 divided by negative the square root of 3. And we'll finish the problem here by writing this in the proper format. In order to do that, we can multiply this, and I know I'm going to run out of space, by radical 3 over radical 3. Whatever the denominator is, we can use to get the radical out of the denominator. We get 2 radical 3 over the square root of 9, but what's the square root of 9? And so we end up with 2 square root of 3 over 3. That's our cosecant value. I'll draw another arrow there. Down here on the cotangent, the same kind of process. We want to get rid of the radical in the denominator, so we're going to multiply by negative the square root of 3. And we're going to multiply that in the denominator. We're going to multiply it in the numerator as well, in the bottom and in the top. 1 times negative square root of 3 is negative square root of 3. Negative times negative is positive. Square root of 3 times square root of 3 is square root of 9. And then the square root of 3 divided by square root of 9 is going to be the square root of 3 divided by 3, which is negative. And it's negative because it was originally. That didn't come out very well. One other thing to point out here is that we're working in the second quadrant. What function is positive in the second quadrant? The sine. So sine and its reciprocal are positive there. All of the rest of these values, cosine's negative in the second quadrant, tangent's negative in the second quadrant, which means that the reciprocal values are also negative in the second quadrant. That goes back to the all students take calculus little mnemonic that we've talked about a couple times this week. But I hope you agree that this looks very familiar, just kind of doing it all in one. If we take a look at 23 pi over 6, once again, what do we do if the angle is not on the unit circle? Well, let's see if we can find it on the unit circle. So what we can do is we can subtract 2 pi. Subtracting 2 pi because it was already a positive angle, so we're looking to see if we've got extra rotations in here, and it's really 2 pi over 1. So we need to find the common denominator. So the 23 pi over 6 isn't going to change, but the common denominator between 6 and 1 is 6. And we multiplied 1 by 6, so we're going to multiply 2 by 6 to get 12. And we've got 23 pi over 6 minus 12 pi over 6, which is 11 pi over 6. Is 11 pi over 6 on our unit circle? Yes. That is our coterminal angle. What quadrant is 11 pi over 6 in? The fourth quadrant. What's our reference angle? And then our ordered pair for this, taking a deep breath here, radical 3 over 2 and 1/2. I have to stop and think sometimes as well. Do either of those need to be negative? The second part, it needs to be negative 1/2. We're in the fourth quadrant. In the fourth quadrant, our ordered pairs all have positive x values and negative y values. So once we identify that fact, and when we go back and look here, sine is the second value, negative 1/2. Cosine is radical 3 over 2. Tangent is sine divided by cosine. So it's going to be negative 1/2 divided by radical 3 over 2. Again, when dividing, don't ask why. Flip the second one and multiply. And once again, what happens is there's a 2 in the denominator, there's a 2 in the numerator. 2 divided by 2 is 1. So what we're left with here, and we're going to need to work with it a little bit more, but we're left with negative 1 divided by the square root of 3. But for now, let's get them all filled in, and then we can go back and rationalize. So when we take the reciprocal of negative 1/2, we get negative 2. When we take the reciprocal of secant of 23 pi over 6, we get 2 divided by square root of 3. Again, secant is the reciprocal of cosine. Cosecant is the reciprocal of secant. We're going to have to rationalize that. Over here for our cotangent, the reciprocal of tangent, we're going to get radical 3 over negative 1. Again, probably better written as negative the square root of 3. But then all that's remaining here, am I going too fast? All that's remaining here is that we need to get rid of the radical in the denominator. So on this tangent, we can multiply by radical 3 over radical 3. And negative 1 times radical 3 is, oh my goodness, negative radical 3. Let me separate this here. Negative 1 times radical 3 is negative 1 radical 3. Radical 3 times radical 3 is radical 9, but what's the square root of 9? 3. And some of them should start to be looking mighty familiar here. So this ends up to be negative, if I could squeeze it in, and it's going to be tight squeeze, negative radical 3 over 3. We actually did at least a similar computation on our previous problem. But once again, if we multiply by radical 3 here, and we multiply by radical 3 there, got to separate again, because there's not enough space. Then we've got 2 over radical 3 times the radical 3 divided by radical 3. We multiply the numerator, the tops together, so we get 2 radical 3. Radical 3 times radical 3 is radical 9, but what's the square root of 9? 3. So our secant value ends up to be 2 radical 3 over 3. So if we flip over our paper here to problem number 4, we've got 13 pi over 2. And your spacing is probably going to be a little bit better than my spacing. But once again, 13 pi over 2, it's not on the unit circle. So all that we have to do is we need to subtract 2 pi. Which means that we want to find a common denominator. And the common denominator between 2 and 1 is 2. So 13 pi over 2 minus 4 pi over 2. 2 times 1 is 2. There's the common denominator. We multiply 1 by 2, so we multiply 2 by 2 to get the 4. And 13 pi over 2 minus 4 pi over 2 is 9 pi over 2. Is that on the unit circle? No. So we subtract again. But the good news is we already found the common denominator, so we're going to subtract 2 pi, which is also known as 4 pi over 2. Well, 9 pi over 2 minus 4 pi over 2 is 5 pi over 2. Is 5 pi over 2 on our unit circle? Nope. So we subtract 2 pi again, and 2 pi is also 4 pi over 2. And when we subtract that, 5 pi over 2 minus 4 pi over 2 is 1 pi over 2 is pi over 2 on our unit circle? Yes. Thomas? No. But remember, I'm not going to give you a calculator. So, just as an aside here, I said that 13 halves was 6.5 pi. And I did 6.5 minus 2 to get 4.5. Minus 2 is 2.5. Minus 2 is 1/2. And I'm okay with that. So the key here is that our coterminal is pi over 2. And this is a quadrantal, which means that it doesn't have a quadrant. But what I said this morning is that I said that the reference angle was pi over 2. Now, I think technically what we talked about when we started this unit is that the quadrantals don't really have a reference angle. So, Ms. Krause and I will still have to talk about exactly what we want to do with that. But I think that we're going to accept either. There's no reference angle or there's the pi over 2. The only reason here is what's the ordered pair at pi over 2? We went over 0 and up 1. So then we can fill in our values. Sine of 13 pi over 2, sine is the second value. Cosine of 13 pi over 2 is 0. Tangent, once again, is sine divided by cosine. So this would be 1 divided by 0. What's 1 divided by 0? Undefined. So now, the reciprocal of the sine function is still going to be 1. But the reciprocal of the cosine function would be 1 over 0. And what does 1 over 0 equal? It still equals undefined. One more thought here. If tangent is sine divided by cosine, and cotangent is the reciprocal of tangent, then cotangent is cosine divided by sine. And cosine value here is 0, and sine is 1. What's 0 divided by 1? It's actually 0.